Hello friends, this is Naina Jangle from Department of Electrical Engineering, Kekeval Institute of Engineering Education and Research, Nasik. In last session, we have seen numerical based on first order curve fitting using least square approximation. Now in this session, we will see numerical on second order curve fitting, that is fitting a parabola using least square approximation. The second order curve is given by ax square plus bx plus c equal to 0. The objective of this session is, at the end of this session, student will be able to apply formulas of normal equations of least square approximation to fit a second order curve or parabola for a given number of data points. Key features of least square approximation. The least square approximation method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offsets or residuals of points from the plotted curve. Least square regression is used to predict the behavior of dependent variables. Least square method is a form of mathematical regression analysis used to determine the line of best fit for a set of data, providing a visual demonstration of the relationship between the data points. Each point of data represents the relationship between a known independent variable and an unknown dependent variable. Now here, one example we have to solve. Now in this example, a RC series circuit is connected across a DC supply of 100 volts. Now as we know, the relationship between voltage and the time across a RC circuit is not a linear, it is an exponential one. So we have to fit the second order curve for the given data points, which are given time in seconds and voltage across capacitor in volts. So the problem is fit the following data point into a second order curve using least square method. Here the number of data points are 6, so n equal to 6. According to least square approximation, normal equations for fitting a parabola or second order curve are given by a sum of xi square plus b sum of xi cube plus c sum of xi raised to 4 equal to sum of xi square yi. Second equation, a sum of xi plus b sum of xi square plus c sum of xi cube equal to sum of xi yi. Third equation, a into n plus b sum of xi plus c sum of xi square equal to sum of yi. So these three equations are called as the normal equations for fitting a second order curve by using least square approximations. These three equations can be written in the matrix form as follows. Now here you can observe the A coefficient is multiplied by sum of xi square, sum of xi and n, that is the number of data points. So here our first column, which is multiplied by A, is A sum of xi square, A sum of xi and n number of data points. B coefficient is multiplied with sum of xi cube, sum of xi square and sum of xi. So that is written in the middle column of the matrix, and the C coefficient is multiplied by sum of xi raised to 4, sum of xi cube and sum of xi square. This is written in the third column of the matrix. Okay, so A into B into C equal to these constants. So we can write, for simplicity, we can write these three equations in the matrix form for solving. Now, as per the normal equations of the least square approximation for fitting a second order curve, it is necessary to calculate sum of x, sum of y, sum of xi square, sum of xi cube, sum of xi raised to 4, sum of xi into yi, and sum of xi square into yi. So for the given number of data points, the sum of xi is 30, sum of yi is 323, sum of xi square is a 220, sum of xi cube is 1800, sum of xi raised to 4 is 15,664, and sum of xiyi is 2196, and sum of xi square into yi is 70,152. So here we get all the sum which are required in these normal equations. So putting these values in the normal equations, that is a sum of xi square, sum of xi is 220, sum of xi square is 220, b sum of xi cube, sum of xi cube is 1800, so 1800b, the c sum of xi raised to 4, that is 15,664, and equal to sum of xi square yi, which is 70,152. So in this way, all the three equations are written by using these sum values. So these three equations are nothing but the simultaneous equations. Our aim is to find the values of a, b, and c such that this equation, second order equation ax square plus bx plus c equal to 0 will get satisfied for all these values of x and y. So solving these three simultaneous equations by elimination method, we will get the values of a, b, and c. A is 1.1429, b is 16.6929, and c equal to minus 0.8393. So writing this a, b, and c in a second order equation, ax square plus bx plus c equal to 0, it is 1.1429 x square plus 16.6929 x minus 0.8393 equal to 0, which is a best fitted curve for the given number of data points. Okay? So this is the second order curve by using least square approximation method. So what is required to fit a second order curve or a parabola for given number of data points? So it is required to find all these sum of xi, sum of xi square, sum of xi cube, and sum of xi raised to 4, sum of xi into yi, sum of xi square into yi, and sum of yi. So if we get all these sum and put in these normal equations, and solving for A, B, and C, we will get a second order curve for the given number of data points. Now there is one exercise for you. Fit a second order polynomial to the following data points. Here the data points are 6. X values are given 0, 0.5, 1, 1.5, 2, and 2.5. And y values are given 0, 0.25, 1, 2.25, 4, and 6.25. So you have to fit a second order polynomial for this given data points. So you take a time and check your answer with this answer. So the sum of x is 7.5, sum of y is 13.75, sum of xi square is 13.7500, sum of xi cube is 28.1250, sum of xi raised to 4 is 61.1875, sum of xiyi is 28.1250, and sum of xi square yi is 61.1875. So after getting all this sum and putting in these normal equations, we'll get these three equations in the form of A, B, and C. Solve these three simultaneous equations, you will get A equal to 0, B equal to 0, and C equal to 1. So you will get here y equal to c. So hope you understand the fitting a second order curve by using least square approximation method. If you have any queries, please drop your message in the below the video. So thank you.